Now then, we can eliminate the logarithm by making both sides an exponent of e. So those essentially cancel. I have sine y over x minus 1 squared equals to e to the 2x plus c. And I think you'll get used to seeing this a lot. Again, we did this in an earlier video. We can break this up into e to the c times e to the 2x. And this e to the c is a constant. So I'm just going to rename it as c. So this becomes c e to the 2x. So now look at this. We can separate and get rid of the fraction here. So sine y would equal to, multiplied by x minus 1 squared, c e to the 2x x minus 1 squared. And I think the only other thing left is that, and I erased too soon, I guess, I can't have division by 0, so x cannot equal to 1. Alright, so that's my solution. Now I haven't checked the book, and I tend to wing these problems in here. I don't work these out in advance normally. I'm thinking through them as I do them on the board, which means that I may have to redo a few videos when I make mistakes. But let's see what the book got here, number 12. They have, well, here it is. Sine y equals 2, x minus 1 quantity squared, e to the 2x plus c. So he kept the e to the 2x plus c up here. All right. He also says that x cannot be equal to 1 and y cannot equal to oh, when x is not equal to 1, y cannot equal to n times pi. Okay. But otherwise, y does equal to n times pi. My goodness, now where did that come from? I'm not sure I'm going to worry about it a whole lot. N times pi, you're looking at the answer in your book, n times pi is a integer multiple of pi. And, well, there we go, because if x is not equal to 1, this is positive, e to any power is positive, a constant is going to be positive, so this has to be a positive answer. And so when x is not equal to 1, that means that this cannot be 0. In other words, y can't be an integer multiple of pi. So this is y not equal to n pi. Now then he has a semicolon that says y equals to n times pi. So in that case, if x is equal to 1, this is 0. 0 times anything is 0. So in that case, y would have to be n times pi. So I would say or x equal to 0 and y equals to n times pi. All right, so it's a little bit crazy there. Those little stipulations. So either that doesn't equal to 0, which means x doesn't equal to 1, which means that can't be 0. Y doesn't equal to n pi. Or the other situation is, what if, oops, I goofed here. If x was equal to 1, then this would be 0. It means y would have to be an integer multiple of pi in order to work out. So there it is. There's our solution to this problem. I'm going to work one more out of this section, one with a particular solution.